In this video, I will discuss the properties and values of the alkaline earth metals group. This group is commonly known as Group 2 on the periodic table. Group 2 consists of the elements beryllium, magnesium, calcium, strontium, barium, and radium. Uses of the elements include beryllium for emeralds and telescope mirrors, magnesium for alloy wheels and flares, calcium for bones and blackboard chalk, strontium for fireworks and treating osteoporosis, barium for rat poison and glass making, and radium for glow-in-the-dark paint. When analysing the structure of all the elements in Group 2, they all have an outer shell with a total of 2 electrons. The full capacity of electrons that the outer shell can hold is 8. Therefore, because the elements only have 2 electrons, the element is constantly trying to rid the 2 outer electrons so that it can be complete. Another similarity within the Group 2 is that all the alkaline earth metals appear in nature, not necessarily in their full form, but making an appearance. For example, magnesium can be found in natural minerals such as dolomite, magnesite, in the form of magnesium oxide. Each of the alkaline earth metals are quite reactive in standard conditions being a temperature of 0 degrees Celsius and a standard pressure. All the elements have a positive charge, are divalent metals, meaning they have a valency of 2 chemical bonds, and can figure basic oxides which react with water to form metal hydroxides, except beryllium, which has a protective oxide layer preventing reaction. For example, barium oxide is a basic oxide. It dissolves in water to form barium hydroxide. Other reactions include Group 2 metals reacting with oxygen to form metal oxides and the reaction with halogens to form metal halide. Group 2 shows an increase in atomic number, mass, and radius. It also shows a decrease down the group for ionization energy. These are common periodic trends that are consistent across the whole periodic table. Going down the group, it is notable that the melting point decreases as the elements become less metallic in nature. Thus, radium has the lowest melting point. As seen in this graph, atomic radius increases down the group as consecutive electron shells are filled. Metallic properties increase going down the group, meaning that the more shells on an element, the easier it is to lose the outer shell electrons, to be left with a full shell underneath. Reactivity also increases going down the group. The positioning of the elements on the periodic table are directly related to their electron configuration. The bottom of the table has a low reactivity level and the top of the table has a high reactivity level. This telling that being Group 2 and being in the top part of the table, alkaline earth metals have a high reactivity level. The element drawn here is calcium. Calcium has a first electron shell with 2 electrons, a second with 8, a third also with 8, and an outer electron shell with 2. All the elements within the group are very similar, being that they all have a nucleus, a first shell with 2 electrons, and an outer shell with 2 electrons. This is why they belong to Group 2. As previously mentioned, the further away from the nucleus the outer 2 electrons are, the easier it is to shed them. Therefore, calcium rids the electrons easier than magnesium or beryllium, but not as easy as strontium, barium, or radium. All of the Group 2 elements have a silvery white colour about them. The atomic radius of the group increases going down the table. This is because the number of electrons within the element also increase. Each electron is further away from the nucleus than the last, therefore causing the atomic radius to increase as the energy level decreases. The metals in the periodic table are mainly found in Groups 1 and 2 and in the central blocks of the transition elements. These are called the S-block metals because they only have 1 or 2 electrons in their outer shell. Group 1 and Group 2 ions and their compounds are important to the natural world of living systems and geology. Potassium and sodium from Group 1 and calcium and magnesium are well known to be important to human bodies. Group 2 is less reactive than Group 1 because Group 1 form ions more readily than Group 2 metals do. The energy required to remove an outer electron from the electron shell is very low, lower than Group 2, whereas the attraction in Group 2's nucleus's charge is larger, due to the presence of more protons creating a greater pull, +2, to the nucleus.